engineer, and I'm working as a researcher at CERTH. And today we will have a session regarding trust, share, and innovate related to data spaces in smart manufacturing. So following a short intro about CERTH and CyclOps project, we're gonna see some key points regarding the data sharing and smart manufacturing, and having an introduction on data spaces. Then we will go a bit deeper in manufacturing data spaces, and we're gonna explore the timeline and what have done so far over these years in this domain with connection to data spaces. We will see some statistics related to that domain and data spaces, and some of the best examples of the operational data spaces that exist for this domain, and the European Commission effort for common manufacturing data spaces. Then we're going to have a short introduction on the offset printing data space that we are working on the CyclOps project, and we can discuss what next on this domain, what we have to expect in the next few years. So starting regarding CERTH, which is the organization that I represent, CERTH is one of the largest research organizations in Greece. It's located in northern Greece. We have 5 institutes. In CyclOps project, in the Information Technologies Institute is the one that participates in order to provide ICT technologies. CERTH is a large organization with over 1,500 employees, and we're running over 2,000 research projects. We have an annual budget around 50 million that is mainly coming from research funding, and we are the hub facilitator of international data spaces for Greece, and this is why we are strongly connected with data spaces on this project and with manufacturing domain as well, as we are participating and running various projects related to Industry 4 and 5. This webinar is part of the CyclOps project that aims to automate end-to-end data life cycle management for fair data integration, processing, reuse. What we're doing in CyclOps project is to promote data ops and AI ops for the full life cycle of data, and see and explore connections with data spaces and try to support different domains of data spaces, including the manufacturing one, which is one of the case studies of this project, and this is why we're organizing this session today. The project is near 9 million, has almost 9 million funding. Its duration is 3 years. As you can see now, we are almost in the middle of the project. We are 1 year and a half. It will be on next month, actually. 24 partners from 11 countries participate on CyclOps. As you can see, we have 5 large companies, including entity that coordinate the project. We have 8 research institutes, a lot of SMEs, 9 is here, and we have also 2 associations in our consortium that are EONAX and Fiber. So let's start going a bit more to the topic for today, which is about data sharing and smart manufacturing. So data sharing actually is the main enabler for smart manufacturing, let's say, as in we're moving from traditional manufacturing to smart manufacturing by applying technologies such as Internet of Things, artificial intelligence and machine learning, and in general, the whole digitalization that enables the further automation of manufacturing. So as you understand, the data sharing is the basis of all of them. You cannot do anything if you're not going to share data and you're not going to use data. So as data sharing is considered as an enabler, we can see here which are the main solutions that are provided by this data sharing, and how it has promoted various fields regarding the manufacturing domain. So first of all, it's the real-time monitoring that we need sharing of data across various machines, various departments, or even various partners in a connected value chain for have some real-time tracking of production and to check the health of the machine and so on. An extension of real-time monitoring is the predictive maintenance, is how we can use this data from monitoring and try to create some kind of predictions and see some kind of early failures and try to, and we can go towards predictive maintenance based on this kind of predictions of both of equipment we can have, such as machines, etc. Another key part that is enabled by data sharing is process optimization. For example, in factories to find how we can optimize, for example, scheduling or find any kind of bottlenecks in a current production scheme and see if we have any flexibility and try to create a more kind of agile production based on it and based on the available data that we have continuously coming off the factory. And algorithms can be fully aware of them and can do this kind of proposals. And of course, the factories are connected to each other, are connected with the supply chain, with many kind of suppliers that can provide various kind of support activities. So the supply chain integration for an end-to-end visibility and traceability is something that is also a very important aspect of smart manufacturing. And of course, in this scenario, we have data exchange, and as you understand here, we can have maybe various challenges as also the data leaves the factory and we have data from different providers coming here. So all of these solutions that we're discussing now also introduce some challenges that we have to address. So if we can see here and if we consider some scenarios that we have some manufacturer that has various suppliers and various customers that connects with his or her data, then we have a series of challenges that is coming here. First of all, we have the data governance to see how you can own your data and how you can provide specific access to your data or not. Of course, we have lack of interoperability. Even if you want to share data, we have to agree, we have to define and agree on specific protocols and specific data models. Another challenge is coming about the lack of trust. If is trusted a third party that I'm sharing the data, for example, to get some analytic services and so on. All of these also solutions introduces various implementation costs because you need to set up infrastructure, you need to add IoT sensors, you need to add some servers or computers for sharing data and so on, and also to set up security mechanisms for them. All this is costs that a manufacturer has to consider. And of course, issues regarding security, compliance, privacy, and so on, as we're talking for data transmission. So this is something that happens to all domains, and same applies to manufacturing one as well. Let's see now how we can move on the data spaces concept and how this concept helps to address these challenges that exist on smart manufacturing scenarios that are based on data sharing. So first of all, the data spaces concept enables the data owner to control who accesses the data, when, and under which specific conditions. So this ensures data sovereignty in data sharing scenarios. This is one of the most important aspects of data spaces and what they provide, because they are beyond only security and interoperability that we will see next. It's a key point of data spaces, this sovereignty concept. Then, of course, we have the security and governance aspects that we described before about using some common identities and access management frameworks that can support a kind of management about who access this data, and of course encryption mechanisms that are used a lot about the security part. And we have also interoperability, both in protocols and also in data models that can be supported on data spaces by using data spaces protocol, of course, and also by adding further vocabularies, let's say, attached in a kind of data space for describing the data that are available in this kind of data space. Here we can see some of the initiatives that support a lot this concept. Okay, the data spaces concept exists for many decades, but it changed a lot in the last decade, and especially in Europe. So a lot of initiatives come to support this activity. So first of all, we have the International Data Spaces Association that focused on establishing and promote the standard of data space for data spaces, and they provide the IDSA reference architecture model that is considered as the cornerstone of what we are thinking was as a data space in Europe. We will see more about it later. Also, there are further initiatives here, such as Gaia X, that provides this digital governance framework for cloud edge technologies. We have the foundation as well with open source implementations and key standards for the development of interoperable smart solutions, and provide relevant concepts and connectors for the data spaces. We have the Big Data Value Association that aims to create an ecosystem for data and AI-driven applications in Europe. Eclipse Foundation as well joins lately in these efforts of data spaces. They set up a dedicated working group. They promote it with a lot of open source components and the support of their community on that. So we have also connectors coming from Eclipse Foundation. And it is important also to say about the Data Space Support Center that was funded by European Commission. So they try to contribute to this plan of European Commission about creating some common data spaces in various domains and verticals. And they try to, let's say, describe the footprints, they try to create some best practices, and they try to support various activities aiming this creation of common European data spaces. Of course, there are more and more initiatives coming to support these data spaces actions. I was trying just here to list the most important of them over these years. And we will see some more specific initiatives for manufacturing data spaces in following slides. But let's have a better look on the IDSA reference architecture model. Even if we are talking for manufacturing data spaces or not, the basis is the same for all the domains. So it's good if we can see and understand better how the data space operates and which are the main roles of the data space. So we have the data owner and the data provider. Okay, the data provider is considered as a kind of both role or device. Okay, if mainly the owner is in most scenarios the provider as well. So the data provider is the one that allows others to use the data and retain controls based on data space artifacts, with the main artifact or component, let's say, to be considered as the data space connectors. So data space connector is a software component that allows the participants to exchange data, but what it mainly does is that enables the provider to attach usage policies on that. This is how enables this data sovereignty that we discussed before. So you can add specific access policies in a data sharing scenario in data asset that is provided through this connector. So a data owner / provider can choose to share data to maybe to a specific party, or for a specific time period, or for 3 times only. So we can consume this API for 3, 5 times, and so on. So these kind of policies are supported by connectors, and this is how they try to enrich this data sovereignty. There are, of course, other components that are considered not mandatory as the connectors, but they are really important, such as the broker. Sometimes this name is misleading because it's mainly a kind of metadata catalog here. So you can add here metadata for describing various data sources. It's related to the assets that are transferred in a data space. And what is transferred through the data space connector. So all these metadata, self-descriptions, etc., are available through a broker. Mainly a broker or metadata, it's a catalog, is a kind of specific data space connector that supports this specific case of holding metadata. What else we have here is the clearinghouse that it's more about logging, let's say, what kind of transactions is done on data space. It's also not a mandatory component. Of course, we have identity providers that are creating, maintaining, and manage the identity information of various participants in the data space ecosystem. This is a very important component as well that works complementary with the connectors. As I described before, we have also vocabularies that are some specific data models. It can be ontologies or whatever to describe data that are transferred through a data space connector. And also, last optional component is also kind of an app store that can be applications that can be related to the data of a connector, and they can be executed in a connector, or they can run outside of it and just use the connector for data consumption or data provision. Besides this IDSA reference architecture, I think that it's good also to mention this data space support center conceptual model, because make more clear at least better how a data space exists and which are the main functionalities and roles. In general, a data space is defined as a kind of governance framework that implemented by some dedicated data spaces infrastructure that complying with this governance framework and can enable different use cases. So a data space is defined by a data space governance framework, and this framework is developed and maintained by a specific governance authority. Also, we want to move further with the definition of data space. Data space is also something that enables one or more data space use cases. So in these use cases, this data space enables specific data transactions that is linked to some data or data products. And this data transaction is between two or more data space participants. So we can have also data spaces that can be just between B2B, because between two actually businesses, and not only large-scale data spaces. Still, this is considered as a data space as well. Also, a data space, as I said before, is considered that it's implemented by some specific data space infrastructure, some specific types of connectors, and so on. So also this is a very important infrastructure part to understand. And of course, we have some, each participant has some specific roles in its data space to provide some specific functionality. So let's try to move now from data spaces to manufacturing data spaces and see a bit better what's going on there. So we can start from a timeline from manufacturing perspective, of course. So from 2015 to 2017, we have the establishment of the Industrial Data Space Project by Fraunhofer Institute, and this leads in the end to the foundation of International Data Space Association in 2018. In 2019 also, Gaia-X come on the scene and try to create an infrastructure, a kind of federated European data infrastructure, especially for cloud solutions, and then some synergies have started to be done between IDSA, Gaia-X, and other initiatives, as you see, especially from 2020 to 2021. We have a lot of alignment with these two initiatives. Also, DVA and Fiverr support them as well. And around 2020, also, we have the European data strategy to be launched by the European Commission. And also in this strategy, data spaces was a core part. Common European data spaces in some key sectors was one of the ultimate goals for this European data strategy. So EC funded a lot of projects related to data spaces. And this happens in years from 2021 to 23. So European Commission create this data space support center as well to try to coordinate this sectorial data spaces developments, and also fund the kind of preparatory action for manufacturing domain, this EU Data Space 4. And we have also some operational and, let's say, real-world data spaces now, not just some pilot cases coming from projects start to be available. It's the one that we will see in the following slides. It's the cutting edge about automotive, the manufacturing edge, and the smart connected supply network. What is happening now in years that we are actually and how we come today? Of course, all these frameworks like IDSA and so on become more mature and now is widely adopted. Now we see that we try to move from further than pilot cases and implementation stages to actual operational ones for manufacturing domain with more scenarios coming up all the time and more demonstrators and so on. And also the European Commission funding moved from preparatory actions for manufacturing data spaces deployment to some deployment actions. Now we have already 2 large projects running on this dimension for manufacturing domain, the smart tenants and the underpin. So if we want to see some statistics about what's going on, we extract statistics coming from bibliography and the IDSA radar. In general, the IDSA has set up this kind of radar for enabling people to add their available data spaces. So in this way, they can try to track which are the available data spaces and see how data spaces evolves and which are the components participate there. So all this information can be available on IDSA radar, but here we present some figures that also coming from bibliography as well, not only for radar. So around 30 cases regarding the manufacturing data spaces have been discovered, and we try to extract some of the application domains that these data spaces operate. So as you can see, most of the cases are related to, let's say, supply chain with the discovery of customers and providers. Of course, we have a lot of cases coming from scenarios for predictive maintenance and machine monitoring, as you can see as well, and the quality of the predictions. If you remember the initial slide that I showed about which are, let's say, the main solutions that are needed, available in smart manufacturing, you can remember, I think, all of them. It's this predictive maintenance, monitoring, supply chain, and so on. Of course, some more specific cases detected here as well about some defect detection and some data sharing just among departments of a company, some demand forecasting as well. Of course, this is based on what was available on bibliography and the radar. That doesn't mean that only these exist, because if the space exists, it's not mandatory to create any kind of scientific or white paper or to add your solution on the radar. But I think it's some good figures here that we can have in mind and see how data spaces will evolve over the years. Regarding the maturity level of manufacturing data spaces, I think this is also a very nice statistic that most of them are still on the implementation stage. Okay, this may happen because also we use also available papers that are mainly on lab or pilot scale, but also by using this DSSC terminology in the implementation stage, we have also the pilot activities, not the actual operational one. So by considering pilot activities also as an implementation stage, that means that most of the outcomes coming from all these research projects, etc., are under this implementation stage. So this is why we have over that 80% now to be still and to be considered still under implementation, and operational is just 10% of them. And of course, we have some that just started and they are under the preparatory stage and try now to move on implementation. Okay, of course, this will always happen as many data spaces will coming, but I think the point is for the next years to start the operational data spaces percentage to grow. And also some statistics were extracted about the various implementations that were used in the data spaces. It's very interesting to see that in many cases there was no reporting no connector use, that this is not very acceptable, let's say, based on what we consider, at least in Europe, as data spaces. We see that maybe more of this not connector use cases coming outside the Europe, because there the data spaces are not that strictly connected to governance and sovereignty as we think in Europe. Then we see a lot of reference regarding IDSA connector without exactly knowing which is this implementation. Of course, we have seen some of well-known implementations coming from data space connector, EDC connector, fiber connectors, and so on. And lately, we have also Soviet connector that is starting and rising, and it's based over the EDC one from Eclipse. And this also, I think, says a lot regarding the lack of interoperability that exists on current data space applications in manufacturing, and maybe this makes it harder to have some common data spaces because most of these connectors are not compatible right now. So let's move now to some more specific cases and see some specific examples of actual and operational data spaces. So in 2021 in Germany, we have the launch of Catena-X, which is one of the first operational data space ecosystems. It's a federated ecosystem for the automotive industry only. It's the first operational implementation of Gaia-X actually, and it's designed to support secure, sovereign, and interoperable data exchange across the full value chain of automotive industry. It was founded by different kinds of suppliers, OEMs, etc., and enabled for them to share safely data with control and transparency. If we check some key concepts and technologies that participate on Catena-X, it's of course the use of Gaia-X Federation services for identity, access management, and trust. Also, it's built over the concept of the IDSA reference architecture. They're using the asset administration cell for modeling and creating digital twins of various assets of the production and automotive industry. The connector implementation that is used in this case was the Eclipse data space connector. Now we have also the Manufacturing X, or International Manufacturing X anymore, that is as well a federated and sovereign and open data ecosystem that's launched in 2023. But the case here is that we try to move now manufacturing domain at all, not only on this automotive one. Actually, Manufacturing X is considered as the industrial scale expansion of the Catena-X model. And they aim to digitalize manufacturing supply chains end-to-end, and they focus a lot on bringing SMEs on that, and not only large companies and the large players. And they're trying to boost resiliency, efficiency, and sustainability, of course, in the whole European industry. Here, if we check the key concepts and technologies, we will see that it's almost the same with Catena-X as we are talking as a kind of expansion here. So we have again the Gaia-X Federation services and the IDSA reference architecture. Again, asset administration cell is used for modeling purposes, and also the EDC connector for the secure data exchange as well. Here we have now the handling of some specific APIs for ERP, mesh systems, and other systems coming from factories, and try to make it a bit more universal, let's say, as we try to move further on from automotive perspective to a more generic manufacturing one. Here we can see actually how all these X ecosystems and for exchange actually are connected now, and where they are placed. So we see this Manufacturing X case. We can see at the bottom that we have all common regulatory frameworks and standards and technical foundation and services that have to be common on all these kind of industry-specific implementations that we can have. So as we said, we had already Catena-X that was at the beginning, it was the first one that were available, and try now to move with Factory X, which is a project that is launched by the German government and support a lot with many components, etc., for factories, and part of this manufacturing X, let's say, ecosystem. And we have now more and more industries coming on this concepts and try to follow these initiatives, such as the aerospace, the robots, and so on and so on. And of course, at the top, they try to be more scalable and transfer across sectors, etc. Also, because it's not only Germany, we have this data for Industry X coming from France. They are also aim to be aligned with Manufacturing X and try to follow the same regulatory frameworks and some services to enable further interoperability in the future, maybe with other countries and so on. But besides what's happened with cutting-edge manufacturing X and all these activities, a very nice example also is this smart connected supplier network. Okay, this case maybe looks like more to be related to logistics. It is about suppliers and not only to manufacturing, but both of these sectors are strictly connected anymore. You cannot have manufacturing without logistics and supply chain on it, actually. So this case is considered as well as part of wider smart manufacturing domain. So this smart connected supplier network, or SCSN, that is mainly known to most of the people. It's one of the first, as I said, operational data spaces. It started in Netherlands. It's quite popular there, especially in Dutch manufacturing. It supports standardized digital communication network to automate various of data transactions and exchange happening there, and try to enable different kind of cases. For example, order and delivery automation through this smart connected network, digital invoicing, demand forecastings over the network of the suppliers, and some of machine and tools sharing. Here, as you can see, we have some different kind of technologies because it is based on a message standard that defines which information is based in a specific format. Is this UBL format, which is based on an ISO standard. They have a kind of four-corner, let's say, model for the technical implementation that is based in the end on this IDSA protocol and the DIN-SPEC standard that had got in previous years. They provide some kind of adapters for the participants in order to connect on this network and have this kind of translation in this information format that they use. And they are compatible with the reference architecture of IDSA and the Gaia-X principles. So they try to represent everything with these providers and consumer format and roles as has been established by this kind of initiatives. Moving now from the operational data spaces and from going to some common European data spaces that European Commission which likes to establish as part of its strategy for data. We will see here that EC is trying to unleash the potential of the data-driven innovation and would like to make in EU level the data available in a trustworthy and secure manner, and they want both businesses and public administration or even individuals to be able to participate on that and have control in the data that they generate and they offer in pan-European level. Here you can see the different sectors that common European data spaces exist, all will be existing next years. As you can see, manufacturing is one of these 14 domains. And there we have the 3 projects that are funded for these activities. So regarding the manufacturing domain, everything starting with a preparatory action with this data space 4. In this project, the focus was first of all to create kind of governance scheme regarding manufacturing by setting up some rules, some kind of soft infrastructure such as functional requirements and so on, and some templates about foreseen federation and scaling up for manufacturing domain. Also, some sustainable business models regarding the data sharing for manufacturing was a part of studying this preparatory action and first models and kinds of agreement mechanisms that will be needed in data sharing scenarios for manufacturing have been set up in this project. Then the project also aims to check and analyze available data sets, what are the priorities on the available data sets, and what is needed to be available in a common manufacturing data space. This should be also driven by the applications that we have so far and makes sense to be available for manufacturing domain. And also they try to create a kind of inventory of existing data platforms that are available in European landscape over the years and see which are the main building blocks. So to try to move from preparation to actual development and deployment. And this is how the story continues with the deployment action. We have two projects here. We have the Entrepin project and the Smart Finance project. And here they try to scale up the deployment and use data spaces for manufacturing to reach some of the critical manufacturing industries here. As you see, Entrepin is mainly focused on asset management and predictive maintenance and try to check all the main aspects of the data space to be operational, so legal aspects, interoperability aspects, business models, of course, and functionality related to trust and security, which is the core part of any data space as well. It's a bit same for Smart Finance. They have more solutions here, not only asset management, predictive maintenance, but they are pretty near to them. They are maybe structured in more categories. And we can see an example here how Smart Finance foreseen to implement this common European data space approach. So to have various data spaces coming from specific companies that are supported by specific data space providers, supported data space connectors. And then over it, they foreseen to create a kind of a data space confederation service, which is under the Smart Finance portal. This services support is actually some kind of shared catalogs about the available data spaces, metadata on these data spaces, some kind of shared ID of these data spaces, and they are using this MX port, which actually a multi-layer framework that is trying to promote the data sharing in a more interoperable way. I have some slides of that later. It's part of manufacturing action from Factory X, actually. And at the top of all of it, Smart has foreseen that this common data space will be nothing more than a portal. So in this portal, you will be able to see all the available connected data spaces with their specifications and the access on these data spaces based on these ID approaches and so on. Let's see something. Let's go now to our approach on CyclOps. Okay, CyclOps is not going to create a common European data space. What we're going to do is to see how we can embed AI ops, data ops, etc., to support further the data spaces infrastructures and make the operations there of higher quality, let's say. So the case that we have on CyclOps is an approach for manufacturing data space for offset printing domain. So we're trying to support this specific domain. No data space for this industry exists, and besides the one that is developed in CyclOps and it's in implementation phase. So we're trying to digitize and standardize the production processes. And here we see how we try to develop novel federated learning and transparent learning models, aiming zero defect manufacturing, anomaly detection, and so on. And of course, maintenance. We will see later about this scenario, and try we also to embrace the circular economy principles. So this is the data space that we have here. We have two different printing companies. We have the Color Print and the Precious printing company. And the idea is how we can set up this data space between these companies, as they have some kind of let's say similar data, and see how we can provide federated and transparent learning to solve these problems between these two companies based on the concept of data spaces. We are using the fiber connectors here, some as you can see. And also we have the service providers of these services. We have two partners for it. It's CERTH that I represent, and also we have Fordot Infinity company, and both of them are providing analytic services for these companies, so to enable this AI and DataOps scenario for the CyclOps data space. As you can see here, we consider data for the full, let's say, life cycle in offset printing company. We can start from sales department. We have data coming from orders. We have data coming from offset printing departments about materials and specific printing processes. We also monitor quality control and to check the final products regarding the printings that are available, and also even until the delivery part and the shipping part. So we have the full cycle here, and we try to optimize various of these activities for this specific data space. What he's done so far is the development of machine learning models, especially about predictive maintenance and the remaining useful life of the product, and some solutions about order to machine selection, etc. So what we are trying to do is to use data from both companies to train this model, but without changing the actual data in this case. Also, we use this BentoML to enable the deployment of ML models and support in general their packaging before we move to deployment, etc., as part of AIOps suite of CyclOps. And also, we try to deliver the scenario with some stream pipes user interfaces at the top of it for each one of these companies, so to monitor various activities regarding the production or the supply chain and so on, as we describe so far. So this is our approach in CyclOps, how to can create something specific and how we can embed more AI on it. We're not focusing only on data setting that the normal data spaces did, but we need also this AI part, as we're talking here, for the full life cycle of data. So starting even from pre-processing, etc. So we're trying to extend a bit the concept of the data space by embedding this AI ops operations and the full life cycle of data, and not staying only on the sharing part that is really nicely covered from existing solutions and existing data spaces. And we have some, of course, setups, our own KPIs that are related to increase the efficiency and control of the production and to minimize product defects and so on. We try to facilitate, as I said, some circular economy principles, as we are handling also the waste related to this offset printing companies, and to try to increase the efficiency of human resources by supporting this ML let's say operations here that we have, and try to reduce any training of models and so on. And this is the last part of the session today. What next regarding data spaces and manufacturing data spaces? First of all, is to scale up. As we see, only around 10% of the available data spaces can be considered as operational. So most of them are now in a kind of pilot phases, on lab testing, on some small applications between a company and the provider or something. Now, I think what is needed is to see a broader picture here and try to cover the entire supply chains, to include suppliers and some more production-ready platforms, let's say, on that. Already some of these activities start to be in place, but it's something that has to be done in next years. Also, to have further interoperability and standardization. As you see before, we have a lot of different kinds of connectors. We have a lot of different kind of data and data formats, and we need to ensure that we will be able to harmonize these data models. For example, we have AAS for that, OPCUA, and so on, and try to check this cross-domain interoperability as well, and to go to these ideas from cross-sectoral data spaces in the case that is needed. If it's considered as beneficial, it's something that is a question mark for many people. And yeah, it's something that have to be evaluated over the years, if it's also beneficial to have cross-sectoral data spaces or not. And maybe we can see that somehow the future start to be here, at least regarding the scale up and how we can set up this kind of interoperabilities. There are some already operational larger scale examples here about how we can connect machine to machine coming from different countries, and to enable this real-time actual communication between the machines. Here we will see a scenario about the product carbon footprint values in a digital product passport, and how this can be exchanged between the machines with the actual technologies that were applied, and also was demonstrated in some fairs this year. So we'll see this export machinery demonstrator here. This is an example of how they use the Orion M export that I described before. So it was an example by using 3 different machines from 3 different countries, and we exchange, and this data exchange was enabled by the FX port. Okay, so as we can see at the right part, this FX port has different layers that starts from some adapters of these applications and built over the converter services. For example, there are different also applications of this FX port. Okay, this is the Orion one that is using OPCUA for this reason, and specific models coming from that. There are, I think, other implementations such as I think the Hercules M export that is based on AAS and so on. So in this scenario, AAS just used on the top of it, not in this converter part, only for DBB description. And these converters, after that, we have this FX gate services. Here is the actual data transfer that we have by using some protocols such as MQTT for this scenario to get the actual data from the machine, and that on top of it, in FX port services, we have the data space connector. So the data space protocol with all the policy rights and so on, the EDC connector is used in this scenario, is used to enable this data transaction of this demonstration of this collaborative creation of this digital product passport of machines regarding this PCF data, that trying to promote further a kind of interoperability between different kinds of equipments, and not just to make interoperability between the communication protocol that we may have also over the years, but still all of them are in progress, and it's nice to see how this will evolve the next years. And the last thing for the future is about what's going on with generative AI LLMs and data spaces. This is a conversation that starting to become more interested over the years or even months. Of course, now LLMs is everywhere, is, let's say, the key story of our days now and the key part of research. So the case here is that many people envisioning interaction of various public systems with LLMs and real-time data access through the data spaces that exist for specific vendors, factories, or even ecosystems, to go to an approach for chatting with your factory, actually. So if you combine both LLMs and data spaces and try to start some chat conversation with your own factory, so an LLM that data on it will be also injected for the factory, and not only from available foundation models and so on. And the other story is how autonomous agents can support decision making, how we can have agents trained with data spaces data and so on, and how we can support some semi-automation or fully automation decision-making in the shop floor. So all these predictive maintenance scenarios that we've seen, so on, to be discussed among agents and actions to be proposed or even taken by them. So some of the scenarios seems a bit futuristic, but even if we consider how the case was 3 years ago before LLMs, also LLM seems to be really, really future, but it's here. What we did also was to study available works about the generative AI and LLMs applications in manufacturing domain. So over 40 works were studied for last 2-3 years. Okay, we consider only the published works on journals and conferences, and we avoid preprints and so on. But still, we were able to find 40 or more works that are really a lot if we consider a couple of years. But at least we tried to do kind of reviews or surveys for other approaches in manufacturing and supply chain, and not only LLMs. And we never find these significant growth numbers. So as you can see in 24, how the numbers were raised here. Okay, we start early 25, so we don't have a lot of applications. As you can see, we have here, for example, enhanced decision making, predictive maintenance, production optimization, supplier discovery. We have all of these concepts that we see in smart manufacturing that is enabled by data spaces and so on. But the case is here, how many now of these applications that are already available for the application of generative AI and LLMs in smart manufacturing, how many of them are connected to any kind of data spaces approach? What we defined that in these 40 works, the number was 0. There is no reference on data spaces and generative AI and LLMs for manufacturing domain, at least. So it's something that seems strange, and think that this will be changed over the years, because, okay, things regarding this Gen AI approach and data space is not that black, because already some white papers from the SSC have been available. Also, scientific papers are now available, not for manufacturing domain, but is how we can connect data space, for example, with RAG operations, how we can ingest data for the embeddings and indexing and information retrieval for RAGs and so on. Also, even in events, for example, here in Athens this week was this data week by BDVA, that data spaces were a core concept, and manufacturing data spaces as well. And there were a lot of discussions and presentations also about generative AI and any connection. So it seems that for sure these two concepts will be packed in the future, and we will start to see some actual applications on this domain of manufacturing one as well. And I think that's all from my side. I slightly covered 60 minutes, so I don't know, Rosa, if we have some time for any discussion, any question, if any. Yes.
We have 2 minutes, so if you have some question.
I have at least one question, which is, you have said that you are in CyclOps, you are contemplating the use of data spaces combined with LLMs to monitor quality of the production. This brings me this question: the production in a factory is subject to change in time, because you may change the product, you may change the machines that you use to make the product. For this reason, you may train an LLM to know how is your current production, how you currently produce a product, you currently make a product, but have you contemplated how the LLM should evolve in time as the production changes as well?
Okay, no, Dario, actually, I didn't say that on CyclOps we're doing that. We're not compiling LLMs for this reason in production and so on. At least it was not part of my presentation. Okay, this connection with LLM was just a part of what's going next, what will be the future, maybe, and see how it is possible. But it's not something that we're doing in this manufacturing case on CyclOps. Okay, so sorry if it was any misunderstanding or misleading from my presentation on that, but it was not.
Well, in any case, it is still a valid question. If in the future anybody wants to combine LLMs for manufacturing, the manufacturing chain is subject to change. In any factory, at least the products can change with time, at least the products, but also possibly the methods will change as well. So if you want to produce any LLM to support that, the LLM should be able to evolve with the manufacturing process as well.
Yeah, see, maybe this is why we don't have actual applications so far. So it's maybe these challenges that have to be overcome in this two domains such as an AI and manufacturing one. Yeah, but it's true. It's a valid comment, I think.
So are there any more questions? Okay, so I think that
Maybe just one question. Where will the presentation be shared? The
we were
slides.
recording it, so we are going to upload it to our YouTube channel. And if you are taking part of the consortium, we are going to share it. We are going to share the presentation with them.
Okay.
Okay, then Rosa, I think we are done. I hope that
Yeah.
people here find it a bit interesting, at least. But
So we can finish. Thank you to everyone for joining us, and thank you, Alexandros, for this interesting training event.
Thank you, Sven.
Thank you. Bye.
Bye.
Right.